Okay, this video is going to talk to you a little bit about pathways. You guys have a little pathway card or pathway cheat sheet. I always struggle with giving students this thing because honestly you don't need to memorize any of these things really. You really don't, okay? You just need to be able to derive them. All right? You have to know about 4 different concepts, and those 4 different concepts are listed right over here. Okay, we've got molar mass. Okay, you know from your previous discussions that molar mass, all right, is something you derive from the periodic table. It is the mass of 1 mole of a substance. Okay, so anytime you're dealing with a mass measurement of any sort, whether you're going to or from, you know that you have to somehow derive that information from that periodic table. Okay, the next concept deals with a mole. All right. Okay, a mole is just that. It's a unit that describes an amount of a substance. And if I have 1 mole of a substance, no matter what that substance is, I know that I've got 1 molar mass of that particular substance. Okay, so for example, if I had 1 mole of carbon, for example, 1 mole, I would then look at the periodic table, okay, knowing that I'd have 12.01 grams of carbon for every 1 mole of carbon. So that's really, really simple to remember. Okay, so when we start determining what our pathway is, we know those concepts. We start dealing with number of particles of a substance, okay, and there's one number that you have to remember. That's the Avogadro number, and I'm going to draw it down here, okay. 6.022 times 10 to the 23rd particles, okay, is equal to 1 mole of a substance, okay, which is also equal to the molar mass of a substance. So if I have the Avogadro number of particles, okay, all right, I know that I have 1 mole of those particles, and I have 1 molar mass of those particles. So once again, we'll go back up here to carbon. If I have the Avogadro number of carbon, all right, and I'm going to do some erasing right here. If I've got the Avogadro number, if I've got this many atoms of carbon, okay, if I've got this many atoms of carbon, I have 1 mole of carbon. I also have 12.01 grams of carbon. Okay, so those all interrelate as conversion factors. Okay, all right. Now, if I have a gas, okay, if carbon happened to be a gas, which would be pretty tough to get carbon into a gas, but if I had, especially at standard temperature and pressure, it will not exist as a gas. So we can't use carbon in that particular case. We could use molecular hydrogen or nitrogen or oxygen. Okay, because remember, when we start talking about STP, that's standard temperature and pressure. Okay, so we have 760 millimeters mercury, or 1 atmosphere. We'll just say 1 atmosphere, STP, is equal to 1 atmosphere, okay, or 760 millimeters of mercury, okay, and also it is equal to 273 K. So this is the standard pressure, and the standard temperature is 273 K. So it has to be following those conditions at standard temperature and pressure. You have the molar volume of a gas is 22.414 liters. That's molar volume. So once again, if I have 1 mole of a gas, we'll try to make this a little bit different color up here. Okay, if I have 1 mole of a gas, I've got the molar volume of that gas. If that is at STP, okay, I have 22.414 liters of that particular gas. So that explains a little bit about what that super secret, triple super duper secret conversion factor is. That should help you some. We'll talk more a little bit about how to use this in the next video.
Made with Doodlecast Pro.